Why the Vought F4U Corsair had Whistling Death nickname. The F4U Corsair evolved from the XF4U prototype, harnessing a robust 2,200 horsepower Pratt & Whitney R2800 and pioneering the inverted gull wing to shorten its undercarriage. Strategic engineering optimized climb and speed. Its 4,600-pound thrust-to-weight ratio surpassed the F6F Hellcat's agility and Seafire's carrier adaptations. Precision control surfaces, advanced fuel management, and integrated armament delivered superior turn performance and multi-role versatility, setting a naval fighter benchmark during World War II. In the F4U Corsair, the inverted gull wing wasn't merely aesthetic, it was an engineering masterstroke. The wing's 7.5-degree downward sweep at the root transitions into a 10-degree upward sweep, fine-tuning aerodynamic lift while precisely aligning the landing gear to absorb vertical loads. Forged from high-strength duralumin, its wing spars incorporated stress relief cutouts that extended fatigue life amid repeated high-G maneuvers. The fuselage's monocoque design, merging magnesium with aluminum alloys, struck a critical balance between weight savings and structural resilience. This composite structure efficiently dampened vibrations and optimally distributed engine torque loads. Precision-honed control surfaces, hydraulically boosted ailerons and elevators with a 25-degree deflection range, were designed to minimize aerodynamic flutter. The careful trade-off between surface area and hinge moment reduced control loads, ensuring rapid responsiveness even during extreme high-angle attacks. Field reports noted that Corsairs could reliably withstand sustained 5.5 G loads, validating the rigorous engineering choices that underpinned its legendary combat performance. The Pratt & Whitney R2800 double wasp engine wasn't just a power plant, it was a mechanical tour de force, powering the Corsair's lethal agility. This 18-cylinder, two-row radial engine boasted a 2,800 cubic inch displacement and delivered up to 2,000 horsepower in its high-performance variants. Engineered for an exceptional power-to-weight ratio, its dry weight hovered around 1,400 pounds, enabling the Corsair to punch through the skies with speeds exceeding 450 miles per hour. The engine's dual-stage, two-speed supercharger maintained optimal boost across varying altitudes, ensuring rapid climbs and sustained thrust during combat. Internally, counterbalanced to rotating assemblies and precision machine components, minimized vibrations and mitigated fatigue, bolstering reliability in prolonged high-G operations. Field assessments from the Pacific Theater confirmed the R2800's unwavering performance under continuous stress, despite its complex maintenance demands. This blend of raw power and engineered resilience was instrumental in the Corsair's standout maneuverability and combat endurance, marking the R2800 as a keystone in aerial warfare history. Mounted along the Corsair's fuselage centerline, the 20mm Hispano cannon delivered a concentrated high-caliber stream of fire. Engineered with a rotary bolt mechanism, its feed system sustained a rate of approximately 750 rounds per minute, launching shells at roughly 730 meters per second. This internal armament was meticulously aligned with the aircraft's center of gravity, ensuring minimal dispersion during high-speed attacks. In parallel, 6 wing-mounted .50 caliber M2 Browning machine guns, each firing around 600 rounds per minute at nearly 880 meters per second, provided a wide, overlapping field of suppressive fire. Their synchronized, staggered arrangement optimized hit probability across variable ranges, with each gun carrying an ammunition load calibrated for rapid, multi-burst engagements. Complementing the internal firepower, underwing bomb hardpoints allowed for versatile payloads, typically supporting dual 500-pound bombs or rocket pods. This external configuration enables swift mission reconfiguration, enhancing strike capability during close air support. Field evaluations noted that this integrated armament system offered a lethal balance of precision internal firepower and expansive external coverage, critical for adapting to the dynamic rigors of Pacific combat. Integrated into the F4U Corsair's design, its defensive countermeasures were a fusion of advanced avionics and robust structural enhancements. The self-sealing fuel tanks, constructed with dual-layered rubberized fabric liners approximately 5 to 7 millimeters thick, effectively minimize fuel loss when struck by 12.7 millimeter rounds at distances up to 300 meters. Reinforced engine cowlings and cockpit frames incorporated 5 to 8 millimeter hardened steel plating, absorbing impacts from stray enemy fire. Simultaneously, the avionics suite, centered around a Mark 6 gyroscopic directional gyro paired with a multi-axis turn coordinator, delivered pinpoint navigational accuracy during high-speed maneuvers. Comparative sensor analysis against contemporaries, notably the P-51 Mustang's instrumentation, revealed a 15% improvement in pilot situational awareness, ensuring rapid response in dynamic dogfight scenarios. Field evaluations in Pacific engagements reported a 25% reduction in critical system failures, underscoring how each design choice in the Corsair's defensive configuration was meticulously calibrated to balance survivability with performance. For carrier operations, the Corsair underwent rigorous modifications. Its arrestor hook was redesigned with a multi-link suspension to distribute distribute deceleration loads across reinforced bulkheads, ensuring reliable capture under high G stress. The landing gear was upgraded with triple-bolted, hydraulic-boosted assemblies rated to absorb forces exceeding 3G, critical for abrupt carrier deck deceleration. In response to saltwater exposure, critical airframe components, particularly the wing spars and fuselage panels, were fabricated from anodized aluminum alloys and coated with specialized corrosion-resistant treatments. These enhancements minimize structural degradation during prolonged maritime deployment. Conversely, land-based configurations shed some carrier-specific weight, permitting the installation of expanded fuel tanks and additional external hardpoints. This trade-off increased sortie endurance and payload capacity without compromising the Corsair's agile handling, evidenced by a documented 15% reduction in landing speed for carrier-adapted models. Field reports from Pacific engagements confirmed these modifications not only improved survivability, but also sustained the aircraft's formidable combat performance across varied operational theaters. In World War II, the F4U Corsair emerged as a dominant force in the Pacific, flying over 64,000 sorties and achieving a kill ratio exceeding 11-to-1 by downing 2,140 enemy aircraft while losing only 189 in air combat. Field reports noted a climb rate of roughly 3,780 feet per minute, a top speed near 446 miles per hour, and a service ceiling of 41,500 feet, underscoring its effectiveness in air superiority and close air support missions. Although originally designed as a carrier-based fighter, its versatility allowed it to excel as a fighter bomber. With an armament of 6 50-caliber machine guns, plus options for rockets or bomb loads up to 3,000 pounds, the Corsair seamlessly transitioned between interception, bomber escort, and direct ground attack roles. Early challenges, such as limited cockpit visibility, were mitigated by tactical modifications, including reinforced landing gear and improved canopies. Pilots lauded its rapid climb and high-speed performance, while ground crews commended its robust build and ease of maintenance, ensuring enduring combat performance and adaptability. The Corsair's economic footprint was as critical as its combat prowess. Unit production costs averaged around $65,000, a figure balanced by multi-source manufacturing across Vought, Goodyear, and Brewster, which streamlined output to peak monthly rates exceeding 200 units. Production efficiency was bolstered by standardized tooling and modular assembly techniques. However, its complex design necessitated specialized jigs and training, inflating initial investments. Maintenance regimens were equally demanding. Engine overhauls and airframe inspections required precision labor, given the aircraft's high-performance radial engine and unique inverted gull wing. Fuel consumption averaged approximately 0.8 gallons per horsepower hour, stressing logistics during extended operations. Supply chain management had to secure high-grade alloys and specialized components, often in competitive post-war markets. When compared with contemporaries like the P-51 Mustang, Corsair's higher upfront cost was offset by a 15% increase in sortie generation and a 20% boost in mission success rates, making it a cost-effective asset in the Pacific theater. These economic and logistical dynamics underscore how production challenges were met with innovative solutions, ensuring the Corsair's enduring legacy. Retrofit modifications further evolved the Corsair's combat role. The AU-1 variant, optimized for low-altitude attack, incorporated a single-stage supercharger and extensive armor, while night fighter variants F4U-5N/5NL integrated radar and de-icing systems. These upgrades addressed emerging threats and adapted the airframe for ground support, ensuring that the Corsair's success endured into the Korean War and beyond, a testament to its versatile engineering and enduring battlefield performance.